Hi everybody. I'm recording this Tuesday morning. I'll see you at the beginning of class today, or by the time you see this, I'll have already introduced it to you. I'm going to be out today, and I've left you one video on some of the problems you worked on last Friday in class. I want to work on 3 more and show you some explanations so you have some more kind of teaching points related to 3 problems, okay? And there are 3 good problems. Your test is on Monday, next Monday, a week from yesterday. We have a review day on Thursday, and then the test on Monday. You're going to see 3 problems that are similar to this, okay? So we're going to start with 17. It's 17, 18, and 19. So why don't right now you get your papers out, be looking at 17, 18, and 19, ready to go. I always draw a diagram. Just draw a right triangle, because there's always going to be a right triangle somewhere. Although the next one is a little tricky, and we'll talk about that. But it talks about a kite flying on the end of a 300-foot string, which we know will be the hypotenuse. The kite string makes a 65-degree angle with the ground. Boom, 65 degrees, 300. Now it's a question of what we're looking for. Are we looking for this side, or are we looking for this side? Which leg are we looking for? How far above the ground is the kite? So we're looking for that length right there. So this is just your typical using trigonometry to find an answer. It's a basic type of problem you got to be able to do. We know this angle. The side we want to find out is opposite. The side we know is hypotenuse. Which relationship uses opposite and hypotenuse? Sine. Sine 65 equals opposite side, we don't know, over hypotenuse. So then we multiply both sides by 300. The variable is up here. Multiply both sides by 300. And you will get an answer of 271 feet. Okay? Basic type of problem, 1 step, that's all you got to do. In the previous video, I gave you that one with the trapezoid, which is a good problem too, but there's layers to it. And number 18 has layers as well. Okay? It can be a little confusing here, and you have to be able to inference how to solve this one. This one's a little bit tougher. You've got to make right angles. 2 12-inch boards are joined together by a hinge. 12-inch board, 12-inch board. The hinge allows the boards to separate at a maximum distance of 8 inches. So there we have 8 inches is the distance between them. That's not a right triangle. We haven't created one yet. But we do have an isosceles triangle. And now this one becomes like number 12. If you want to go back to number 12, I did it on the earlier video. If we drop this, actually let's finish out what it says. What's the maximum angle the hinge can open? So we're trying to find this angle right here. What's that angle measurement? If we drop this as a median, this is 8 inches, this is 4 inches, this is 4 inches. So now we have 2 side lengths. That means we can figure out this angle, and then we'll just double it to figure out the other half. Okay, so we don't know this angle. We want to know it. It's X degrees. But we do know the opposite side. We do know this is the right angle. And we do know the hypotenuse. So we're opposite and hypotenuse again. So we're dealing with sine. Sine of x degrees. We don't know the x degrees, but we do know opposite over hypotenuse. And this is the inverse. We did a day on this last week. How to figure that out? X degrees, sine inverse, 4 divided by 12. And when you do the sine inverse key, 4 divided by 12, you will get 19.5 degrees is the measure of this angle right here. But we're looking for both of them, so we have to times it by 2 to get 39 degrees. If you got 38.9 or 39.1, perfect, you're right there, okay? That means you've done everything right. Again, showing me the work, really helpful to give you some partial credit along the way. Okay, so we've got these two done. Two different types of math. You know, pretty basic, straightforward. This one you've got to be able to create the right angle from it. So it takes some inferencing to be able to figure that out. Okay, last one, pretty basic. An escalator in the Atlanta subway makes an angle of 10 degrees with the horizontal. There's our horizontal, here's our escalator. It makes a 10-degree angle. Travels 59.1 feet horizontally. What's the length of the escalator? Again, pretty basic problem. One step, pretty easy. We know the adjacent. We're looking for the hypotenuse. Adjacent and hypotenuse. A and H. Look on your board. It's cosine. Cosine 10 degrees is equal to 59.1 over x. I like this one is different than 17. The variable is here. Swap them out, right, Ruben? Swap them out. X equals 59.1 over cosine of 10. And x will equal 60 feet. It's a 60-foot escalator. All right? So, 3 types that you're going to see in terms of the word problem, the way it's set up. Pretty easy, a little bit more complex, but this type of math, how to solve this one, as opposed to with the variable in the numerator. And then using inverse. Okay, so 3 really good types of problems. I hope you're good at these. Take the time, maybe even watch this video a second time, and be able to be fluent in these problems. Have a good day, you guys.